Hi guys, we are entering into like the second half of our polynomial unit. The first half we practiced like multiplying things and adding and subtracting. Today we're going to be starting factoring, which is what we're going to be talking about the last 3 lessons of the unit. And factoring is essentially just like dividing. So it kind of makes sense. We did adding, subtracting, and multiplying. We're ending with dividing. Now, hopefully this first thing you've heard of before, a greatest common factor, or we'll just use like the letters in front, which we'll say GCF. Now, think to yourself what a factor is. Well, a factor is something that can be multiplied by another number or term to produce some quantity. That sounds really fancy, but if I just asked you, hey, what are 2 factors of 36? All you would have to do is tell me 2 numbers that multiply together to be 36. So maybe like 2 and 18. Those are factors of 36 because they go in to 36, or you can multiply it by something else to get 36. There are other factors of 36. You could have said like 3 and 12. 3 times 12 is 36. Or you could have just said 6. 6 times 6 is also 36. So all of those numbers are considered factors of 36. They're numbers that go in evenly to 36. So that's a factor. Now a GCF, a greatest common factor, is the biggest factor, obviously because we say greatest. It's the biggest factor that goes into 2 or more terms. So it's the biggest factor that 2 or more terms have in common. Now in algebra, realize that the GCF, which maybe this is different from what you've seen in the past, you've probably done GCFs before, but maybe you only did numbers. So in algebra though, we're going to do numbers and variables. So we're going to throw x's, y's, all that good stuff in. But let's start off with just numbers. So here's an example of you figuring out like GCFs. They're going to say find the GCF of each group of numbers. So say they say 10 and 20. You want to tell me what's the biggest factor of both of these numbers. Now some of you could see it right away. If you're not sure what it is, here's the process of how you would figure it out. So you'd start by listing all the factors of 10, or basically just all the numbers that multiply to be 10. So I could say 1 times 10, so 1 and 10. 2 times 5. Those are the only combinations of things that multiply to be 10. So those are my factors of 10. 1, 10, 2, and 5. If I did the same thing for 20, I can multiply 1 times 20. I can do 2 times 10. And I can do 4 times 5. So these 6 numbers are all factors of 20, numbers that go into 20. Obviously, if I'm finding the GCF, I want to find the biggest number that both of these groups have in common. So if you can't see it, it's 10. So that would be the GCF, biggest number that goes into both 10 and 20. I could do the same thing for the next group if it's 3, -12, and 15. I could break down the factors of each number individually. So 1 and 3, it would just be 1 and 3. It's the only combination of things that can be multiplied to get 3. For the -12, I wouldn't even worry about the negative there. I'm just going to cross it off. Just think about factors of positive 12. Because you never make your GCF negative unless all the numbers are negative, which they're not, and they're usually not. So 1 and 12, 2 and 6, 3 and 4. Those are my factors of 12. And then 1, 15, 3, and 5, those are factors of 15. So compare each group and look for the biggest number they all have in common, which is going to be 3. Hopefully you do not have to make this list, guys. Hopefully you can just look at the numbers like 6, 24, and 18, and you can figure out what's the biggest number that goes in to all those numbers. If you need to make the list, do it, but hopefully you can see on this letter C here, the biggest number that goes into all of those is 6. 6 divides in perfectly to all those numbers. All right, let's use the same idea and practice with some variable examples. So they're going to ask you the same question. They're going to say, find the GCF of the polynomial. So you basically just have to look at each term. So I've got 2 in this one. This is a binomial. and I've got to list out the factors of each term. So you do the number and the variable separately. So for A, I'm going to look at the 5 first. And I know I just do 1 times 5, and those are my only factors of 5. Then look at the x to the 5th. And think to yourself, what multiplies to the x to the 5th? Well, really, it's just x times x times x times x times x. And then I would do the same thing for the second term, 10x cubed. So I'd break down 10. I can do 1 times 10 or 2 times 5. And then the x to the 3rd is just x times x times x. When you say the GCF, what these two terms have in common, the biggest thing they have in common, you look at the numbers and you do what we did up here. So I see that 5 is the biggest number that they have in common. And then you look at how many x's they have in common. Well, this one only has 3. This has got more than that, so the amount of x's they have in common is just 3. So I'm going to say x to the 3rd on my GCF. Now, trick here, and I'm going to make a little note. For variables, to say what the GCF is for like the x's or whatever variable it is, you're just going to choose the smallest exponent for the GCF. And I'll show you what I mean here. So let me go ahead and do example B here. And again, hopefully you don't have to make these lists. That's pretty time consuming, and I don't want you guys to have to do that. So for B, I'm going to look at the numbers first. Ignore the negative because they're not all 3 negative. So 2, 10, and 6. What's the biggest number that goes into all 3 of those? Hopefully you can tell that it's 2. Then for the x's, so this is x to the 4th, x squared, x to the 1. There's 4 x's here, 2 here, 1 here. They all have at least 1 x, each of these terms, so that's going to be the greatest amount of x's they have in common. Or in other words, you just choose the smallest exponent to put on your GCF. So 4, 2, and 1, obviously 1's the smallest. That's what goes on my GCF, x to the 1. Now for C, same idea, look at the numbers first. And always try the smallest number, like see if 3 goes into the others, and it does. So that means 3 is going to be the number for your GCF. X's, you've got 2, 1, the 9 doesn't have any x's. That means all terms don't have x's in common, so you cannot put any x's on the GCF. The GCF would just be 3. Alright, so the idea of finding a GCF is crucial to be able to factor or like divide polynomials. Okay, so that's kind of like the goal for today. GCF is part of it. Here's what we're really trying to get after. Now, when you factor, and a big part of this is knowing what factoring means. So when you factor a polynomial, you're really just being asked what can be multiplied together to get that given polynomial. Okay, so you're just thinking, like here's my example, what can I multiply together to get this thing right here? I want you guys to just think of factoring as reverse distributing. So here's what I mean by that. We all know how to distribute. Let's say I give you this problem. 2 times 3x plus 5. Everybody knows I just distribute the 2 and I would get 6x plus 10. Factoring is going to be the opposite of that. So they're going to give you 6x plus 10, and you're going to say, oh, a GCF. Let's see, both of these terms have a 2 in common, so I'm going to pull that out, and what's left over would be 3x plus 5. You probably don't know how to do that already. I do. That's what I'm about to show you. But it's just the reverse of what a distributing problem would be. So it goes along really nicely with what we've already been talking about and learning this unit already. Okay, so let me walk you through some steps. So steps for factoring. The first thing you have to do is find the GCF, what we were doing on the front. So maybe let's take it step by step. For example, A here. So step 1, 5x and 10. Look at the numbers and the variables separately. So 5 and 10, the biggest number that goes into both of those is 5. The 10 has no x's, so that means they don't have any x's in common, these two terms, so I can't put x's on the GCF. Okay, cool. So GCF is 5. Step 2, you want to divide each term by whatever you got for the GCF. Okay, so here's what I mean by that. You want to take what you started with, 5x plus 10, and you want to divide both terms by the GCF, which we said was 5, and then figure out what is left over when you do that. So 5x divided by 5, the 5's just cancel and you have x, and then 10 divided by 5 is obviously just 2. Okay, so I'm going to call that the leftovers. All right, so once you've done that, the last step is you just write your answer. Since we're thinking of factoring as reverse distributing, you're just going to write your answer as a product. And if you're not sure or you forget what product means, product just means like multiplication. So you're going to write it as a multiplication problem. And what the two things you're going to multiply are the GCF and what you got as the leftovers. Okay, so in other words, your answer should look like this. GCF on the outside, that's the thing that's getting distributed, leftovers in parentheses. So check it out for this first example here. The GCF was 5, so I stick that on the outside. The leftovers were x plus 2, I put that on the inside. So this is my answer. And your answers, you can always check them on these, which is awesome. If you just distribute the 5 back through, you should get what you started with. And I do on this one, so I'm good to go. All right, let's do another one. So if they say factor this, you basically want to find the GCF and you want to pull it out front and write what's left over in parentheses. So it looks like a distributing problem. GCF first. So, okay, analyze your two terms, 8 and 12. Well, the biggest number that goes into 8 and into 12 is 4. Then for the x's, I'm going to use the smallest exponent, so that would be x to the 1. So I've got my GCF. Now I need to divide the problem by what I got for the GCF, which was 4x. So divide every term by that to figure out what's left over when you pull 4x out. So 8 divided by 4 is 2. Remember your exponent rules. 2 minus 1, that would just be x. And then minus, that would be 3, and the x's would cancel. Okay, so those are your leftovers. Now I can write my answer. Should look like a distributing problem. The GCF goes on the outside. Leftovers go on the inside. 2x minus 3. Again, guys, you can check this. So distribute it back through. 4x times 2x is 8x squared. 4x times negative 3 is negative 12x. And yeah, that's what I started with, so I'm good. Okay, I want you guys to try example C, and then I'm going to do D to finish this off. Step 1, find the GCF. Don't worry about the negatives, they're not all negative, so I'm just going to make the GCF positive. 3, 9, and 27, 3 would be the biggest factor of all those numbers. For the y's, I'm going to use the smallest exponent. They all have at least 2 y's in common. Now I'm going to take the problem and I'm going to divide each term by the GCF, which we said was 3y squared. See if I can fit this in here. Okay, so negative 3 divided by 3 is negative 1. Subtract the y's, that would be y to the 4th. 9 divided by 3 is 3, and that would leave me with 1y. And then negative 27 divided by 3 is negative 9, and the y's would cancel. So that's my leftovers. Now I write my answer as a distributing problem. So get your GCF on the outside, get your leftovers on the inside, and remember that you can distribute it back through to check, but I know I'm good.